Welcome to Digital Learning, Department of Collegiate Education. I am Dr. Vanaja V, Assistant Professor, Department of Mathematics. In this video session, we are going to learn how to solve the problems on reduction formula for integral 0 to pi by 2 sine to the power n of x dx and integral 0 to pi by 2 cos to the power n of x dx. Recapitulation of previous session, that is reduction formula for integral sine to the power n of x dx and integral cos to the power n of x dx and some examples. The learning objectives are to apply reduction formula for integral 0 to pi by 2 sine to the power n of x dx and integral 0 to pi by 2 cos to the power n of x dx to evaluate given integrals. The learning outcomes are able to apply the reduction formula for integral 0 to pi by 2 sine to the power n of x dx and integral 0 to pi by 2 cos to the power n of x dx to evaluate given integrals. Prerequisites are list of integral formulae, methods of integrations, properties of definite integrals, and reduction formula for integral 0 to pi by 2 sine to the power n of x dx and integral 0 to pi by 2 cos to the power n of x dx. So let us recall the formula, that is in equals to integral 0 to pi by 2 sine to the power x dx, which is equal to integral pi by 0 to pi by 2 cos to the power n of x into dx. Here for the, if n is odd number and n is even number, which are the formulas means. So n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 up to we can get the multiple by 2 by 3 when n is odd. So similar way we can give the formula for integral 0 to pi by 2 sine to the power n of x dx and integral 0 to pi by 2 cos to the power n of x dx. Both are same formulas, that is n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 up to we can write the multiples as 1 divided by 2 and at the end we can multiply pi by 2 when n is even. So to solve the reduction formulas based on this particular formulae, we have to recall the properties of definite integrals. Here I have given the list of properties of definite integrals. Let us go through these properties. Integral a to b f of x dx can be written as integral a to b f of t dt. Second one, integral a to b f of x dx can be written as a to c f of x dx plus integral c to b f of x dx when a is less than c, c is less than b. And integral a to b f of x dx, which is equal to minus integral b to a f of x dx. And integral 0 to a f of x dx, which is equal to integral 0 to a f of a minus x dx. Next one, integral a to 2 times of 0 to 2 times of a f of x dx, which is equal to 0 to a f of x dx plus 0 to a f of 2a minus x into dx. Next one, 0 to 2a f of x dx can be written as 2 times of 0 to a f of x if f of x equals to f of 2a minus x, and 0 to 2 times of a f of x dx equals to 0 if f of x equals to minus of f of 2a minus x. Next one, integral minus a to a f of x dx, which is equal to 2 times of integral 0 to a f of x dx if f of minus x is equal to f of x, or we can say f of x if f of x is an even function. And the next one, integral minus a to a f of x dx equals to 0 if f of minus x, which is equal to minus f of x, or the given function is an odd function. So based on these properties of integral, integrals, we can solve some of the problems. So evaluate the following. First one, here it is given integral 0 to pi x into cos to the power 6x into dx. Let I equals to integral 0 to pi x into cos to the power 6 into x dx. Then using property of definite integral, that is I equals to integral 0 to pi minus x into cos to the power 6 into pi minus x dx, which is equal to integral 0 to pi minus x cos to the power 6x into dx. We can use the integral definite integral formula, that is integral 0 to a f of x dx equals to integral 0 to a f of a minus x into dx. Just I have used this one here. So in this case, cos to the power 6 pi minus x. See here I have just explained here. Cos of pi minus x, that is we'll get it in a second quadrant, that is minus cos x. But cos to the power 6 of pi minus x is equal to minus cos to the power 6. That is nothing but cos to the power 6 of x. So we can rewrite here cos to the power 6 into pi minus x can be written as cos to the power 6x into dx. So multiply this pi with this cos to the power 6 of x into dx and also this x. So again we can write I equals to integral 0 to pi into cos to the power 6 of x dx minus integral 0 to pi x into cos to the power 6 of x into dx. As we already denoted, this is integral 0 to pi x into cos to the power 6 of x into dx is equal to I. So this I, if I send to the LHS side, so it becomes I plus I is equal to 2I, which is equal to, so pi is a constant, we can take out of the integral sign, then pi into integral 0 to pi cos to the power 6 of x into dx, which is equal to, again we can use the property of definite integral, that is integral 0 to 2a f of x dx equals to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x into dx. So we can use that one here. 0 to pi by 2. Here a is pi, so 2a is pi, so a becomes pi by 2 cos of 6 cos to the power 6 of x into dx plus integral 0 to pi by 2 cos to the power 6 of pi minus x into dx. So this we can write, already here we are having cos to the power 6 of pi minus x. Again we can write that is nothing but cos to the power 6 of x. So here we are having cos to the power 6 of x minus pi can be considered as cos to the power 6 of x into dx. And here also we are having cos to the power 6x into dx. If I'll add these two things, we'll get 2 times of integral 0 to pi by 2 cos to the power 6 of x into dx, which can be written as 2 pi integral 0 to pi by 2 cos to the power 6 of x into dx. And here 2 we are having, here 2 we are having, both the 2 get cancelled. So we can write I equals to pi into 0 to pi by 2 cos to the power 6 of x into dx. We can use the reduction formula. Here n is an even number. At the end we can just multiply pi by 2. The formula runs like this way. That is pi is a constant value, we can write as it is. Here 6 is there. N minus 1 divided by n, that is 6 minus 1 is 5 divided by 6 into 6 minus 3 divided by 6 minus 2 is 3 by 4 into 6 minus 5 is 1 into 6 minus 4 is 2, that is 1 by 2 into pi by 2, which yields a result like this way, 5 into pi square divided by 32. Here the second problem, that is integral 0 to pi by 4 cos to the power 6 into 2 times of x into dx. Till now we have explained the term of a single angle, that is cos x, sin x, like this way. But here they have given here cos to the power 6 into 2 times of 2x. So how to evaluate this one means we have to first simplify the term of 2x in terms of x. So for that, let I equals to integral 0 to pi by 4 cos to the power 6 into 2x into dx. Put 2x equals to t here. So to simplify and to consider in terms of a x or any other term t. So to put 2x is equal to t, therefore dx equals to half into dt. So again here the limit we are considering here for the term of x. Here for x is equal to 0, then t becomes 0. And x is the pi by 2, then the t becomes pi. Your x is pi by 4, then t becomes pi by 2. So therefore t varies from 0 to pi by 2. But in the given problem x varies from 0 to pi by 4. But after substitution t varies from 0 to pi by 2. So the I we can rewrite here I equals to 0 to pi by 2 cos to the power 6 into t, and your dx can be taken as dt by 2, which is equal to, take out this 1 by 2 outside, half integral 0 to pi by 2 cos to the power 6t into dt. We can use the formula that in equals to integral 0 to pi by 2 cos to the power n of x into dx is nothing but n minus 1 divided by n into n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4 up to pi by 2, because here n is a even number. So same thing I have applied here, and here which is the result like this way. Here I am having half is common. So 6 minus 1 is 5 divided by 6. Then 6 minus 3 is 3 divided by 6 minus 2 is 4. 6 minus 5 is 1. 6 minus 4 is 2. Then I can multiply pi by 2. After simplification, we'll get the value 5 into pi divided by 64. Similarly, we can solve this problem here. The problem is given like this way. Integral 0 to 3 times of pi into sine to the power 6 into x by 6 into dx. Again here it is not a single angle of sine, or here it is the angle is given as x by 6. So we have to change as a single angle. For that, consider I equals to integral 0 to 3 times of pi sine to the power 6 of x by 6 into dx. So here put x by 6 is equal to t. X is equal to 60 it becomes. Differentiate this x with respect to t, will get dx is equal to 6 dt. Here x varies from 0 to 3 pi. So we have to check how t varies. So here t varies from 0 to pi by 2. See, if x is equal to 0, t becomes 0. If x is equal to 3 pi divided by 6, 3 ones are 3 twos are, t becomes pi by 2. So the entire problem we can rewrite in this format, that is I equals to integral 0 to pi by 2 sine to the power 6t into 6 times of dt. Here I have used the property of first integral, definite integral, that is any integral of the form integral 0 to a f of x into dx can be written as integrals a to b f of t dt. So here similarly we can write, and 6 is a constant, so 6 times of integral 0 to pi by 2 sine to the power 6 of t into dt, which is again we can use the formula. Here I have given the formula for if n is even at the end, we can just use pi by 2, or k we can use as pi by 2. So here n is 6. So 6 minus 1 is 5 divided by 6. Again 6 minus 3 is 3 divided by 6 minus 2 is 4. Again 6 minus 5 is 1 divided by 6 minus 4 is 2. So altogether we are having some values here and we have to multiply pi by 2 because here n is an even number. So after simplification it yields as a result as 15 into pi divided by 16. See here I have considered the different problem in terms of sine as well as cos using the definite integral properties, that is integral 0 to pi is given and here the function f of x is given in the form of a ratio or a fraction, that is in the numerator sine to the power 4 of x whole divided by 1 plus cos whole to the power 2 into dx. First, we have to simplify these trigonometrical terms. So, we can write sine 2x in the form of 2 times of sine x into cos x. But if I'll take that x in terms of half angles, that is sine of 2 into x by 2, I'll get sine of x. Sine of x can be written as 2 times of sine x by 2 into cos x by 2. And here the sine as having the power 4, so into the power raised to 4 whole divided by 1 plus cos x can be written as 2 times of cos square of x by 2 whole square. So just simplify here. This we can write 16 into sine to the power 4 of x by 2 into cos to the power 4 of x by 2 whole divided by 4 times of cos to the power 4 x by 2. Cos to the power 4 x by 2, cos to the power x by 2 get cancels and 4 ones are 4 fours is 16. So we can write I equals to 4 times of integral 0 to pi sine to the power 4 x by 2 dx. Again here the angle is half angle. So we have to consider the full angle because we are having the reduction formula for the full angle. Then for that sake put x by 2 equals to t. Then dx becomes 2 times of dt. Here x varies from 0 to pi, so we can convert that one to t. It varies from 0 to pi by 2. And again here if we can rewrite, that is I equals to 4 times of integral 0 to pi by 2 into sine to the power 4t into 2 times of dt. So 2 is a constant. We can take out from the integral sign outside. 4 2 is a 8 will get, and here 4 is an even number. We know the formula. If even number is there, we have to multiply pi by 2. Here the formula runs like this way. 4 minus 1 is 3 divided by n4 into 4 minus 3 is 1 divided by 4 minus 2 is 2. So after simplification, we get an answer like this way. 3 times of pi divided by 2. Here again we are having a one more problem, that is integral 0 to pi into 1 plus cos x whole raised to 5 by 2 into dx. As we already discussed in the previous problem that 1 plus cos of x can be written as 2 times of cos square x by 2. So we are expressing that cos x in terms of a half angles here. So we can write let I equals to integral 0 to pi into 1 plus cos of x whole raised to pi by 2 into dx. This 1 plus cos of x pi to the power of pi by 2 can be written as 2 times of cos square x by 2 whole raised to 5 by 2 into dx. Here we can just take out the common terms or constants. We'll get 2 to the power 5 by 2 integral 0 to pi cos square x by 2 whole raised to 5 by 2. This 2 and this 2 get cancels and we get like this way, that is 2 to the power 5 by 2 integral 0 to pi cos to the power 5 x by 2 into dx. Again it is in terms of half angles, so put x by 2 equals to t. Therefore dx equals to 2 times of dt. Here t varies from 0 to pi by 2. X varies from 0 to pi. So t varies from 0 to pi by 2 because t equals to x by 2. Applying these limits, We get I equals to 2 to the power 5 by 2 integral 0 to pi by 2 cos to the power 5 of t into 2 into dt. So here we are having the formula, that is integral 0 to pi by 2 cos to the power n of x into dx. When n is odd, at the end just we can multiply 1 here. The formula runs like this way. And here 2 to the power 5 by 2 plus 2 we can write, and the remaining we can apply the formula. After simplification, we get an answer as 64 into root 2 divided by 15. Here, because 2 to the power of 5 by 2 is there, that we can write under the root 5 times 2. So we can write that is 2 to 4. We can take outside. Then 4 2 is 8. 8 2 is 16. 16 4 is 64. Root 2 in the numerator. And the denominator we are having two terms, 5 as well as 3. 5 3 is 15. So like this way, you can also solve these problems, and we are familiar with the formulas, and these are the reference books. This is about the integral of 0 to pi by 2 sine to the power n x dx and integral 0 to pi by 2 cos to the power x into dx.